Hi and welcome back. Today's episode is about spider plot. What is the spider plot and how to read it, how to build it using R. Why do we call it radar? We are going to explore how to use ggplot2 and more libraries plot this amazing visualization to compare categorical variables and groups. You will learn how to use pivot wider and the library Tidyverse. Let's see next how to plot with R now. First of all, we need some data to build this amazing visualization that is the radar or spider plot. We're going to use the information coming from the Titanic disaster, and we're going to get some information from our passengers. As you can see here, we have different variables: passenger ID, survive, class, the name of the passenger, sex, age, ticket, fare, cabin, and so on. Okay, but if we want to use the radar plot, we need to compare something. For example, here we can compare sex, the number of different passengers divided by sex, or by the passenger class they took in this ship. Okay, we're gonna use in this case, for example, P class. However, P class, as you notice, is a number, so we have to transform this information from numeric to categorical. How do we do that in R? Calling the function factor. Now, P class is transformed. As you can see here, we can come back here. P class is now a factor with three levels. Three levels because we have first, second, and third class. The same for sex, which now is a string. However, calling the function factor, we transform it into a categorical variable, and you can see here, sex is now a factor with two levels, female and male. Now, once we have done this, we can compare. For example, we can compare the number of males in first class, number of males in second class, and the same for female. Radar is the same code as spider due to its visualization, its structure. And it's in here, we can use the function str2, and we call Tidyverse. Why do we need Tidyverse? We're going to use some function from Tidyverse, and we call it to do what? Well, because we need to count. We need to count all the different or the number of passengers in each class. As we discovered in previous videos, the function count and the pipeline. The pipeline is used to say, okay, this information from my Titanic, we're going to send it to the function count, and it's going to take some variable from my data. It's going to count the number of passengers. I need to calculate that percentage for each class. In this case, as you can see, sum is going to add all the information from the column N, 2 and 16, 1 and 84, 4 and 91, and every observation divided by this total, that is 891 observations, and we're going to send it to the variable or the new variable called percentage using the function mutate. As you can see here, we have the different percentage. 24%, 24%, 55%. Okay, right now we have all the information in the same scale from 0 to 100. Okay, and we're going to save this one in my data. Some new data frame called my data. And it's important now that we need to see all this information not as one single long format. We need a wide format. That's how we can plot a radar. We need a long format. How can I change this long format? Well, we need to change it to a wide format. In this case, we use pivot wider. Pivot wider from the library Tidyverse. In the library Tidyverse 2, we are going to change it. And then we say, okay, name from P class. That means that we're going to have all these numbers, 1, 2, 3, and the values from percentage. So we're going to change all this information from these numbers, passengers 1, 24, a new column called 2 with 20%, and a new column called third. I'm going to give that value 55%. Let's see how it works. And check that I'm going to use only two columns. The first one, P class, and percentage. I'm not going to use the end because I already calculated the percentage for each class. Let's see. Temp is calculated. Temp, we're going to see. As you can see, as I told you, is one column per class corresponding with the percentage. Okay. So we transform all this into a one single observation, but with 3 columns. What's wrong here? Okay, the name of each column is something we have to change. Again, we can see here. Check something useful. How to plot this information? We calculate before with a percentage p class corresponding to each class in the corresponding percentage. This is not what I want to show you, but it's important to notice that we're going to compare. Oh, the first class has less or had less passengers than the third class. Yes, but I want to see different, right? They want to see it like a radar, like a spider web. Okay, then we're going to try to transform all this information using this pivot wider information, but for that we need the library ggradar. Okay, let's install it. Now, once we have done this, we can call ggradar and voila, it's simple. Remember, I'm gonna let you to use this information and now ggradar. Remember that temp is different than this plot we have to the right. This one was only using the information from my data. Meanwhile, this one is temp using one single observation. However, each column represents every class. And here through ggradar is expecting columns, and we see here. Let's call ggradar. Let's see. Oh, here we are. So something wrong here. 2 and 3. We don't have first class. What's going on? The percentage looks good. 55% for third class. But there's a problem. Well, it could be giving different values to our data frame. Now remember that temp had a problem that was each column, right? 1, 2, 3 was a little bit weird. So let's say P class is the name of our information with values called temp. So you can see here, okay, that's information here. We're gonna save it in values, all the information from temp, and all the name for this is gonna be P class. Let's see now temp. Okay, here, temp. So you can see, oh, and variable now is called name and values corresponding to the observation. Oh, you can see here, a new column called name, P class, however, x1, x2, and x3. Something we have to change. So we call the names differently now, P class, C1, C2. Oh, so the problem was that the number 1 here in this plot to the right was thinking that the class number 1 was the variable name. So it's a problem here. And now we have 4 columns, as you can see, and we can change them using the function called names to this data frame called temp. And let's see now temp. Let's see. Okay, perfect. P class is 1 column, C1, C2, and C3 is gonna be our columns. And let's see now, this looks so different. You see here. Here we have the different information I built. Can you see here now 30, 60% is going to correspond all to all these values. Here I have labeled in these circles, the inner circles and the outer circles. And how I control that? Using grid min, grid mid, and grid max. Can you see 30% is for grid min, 30% from grid mid, 60% for grid max. I use these values because I have my information in temp. I'm going to repeat this information. I have my information with relative frequency, not with percentage exactly. So let's see now what is the output. Here we are. Now, as you can see, third class, you can call it different if you want to. Third class is the longest part in my radar. C2, A3, 1 exactly. Let's see. Now, let's compare a little bit better now, but using with sex. We're gonna do the same. Remember that we had sex grouped by male and female, but this one here doesn't look like we're comparing anything, just the class. What if we add the sex, right? Let's see this new information. If we use group by, we're gonna try to see the different comparison of sex in each class. You can see male and female by class. Okay, and now we calculate the percentage for each corresponding sex. As you can see here, Now 60% of male were third class, 80% of male were in second class, and 25 corresponding to first class. And we save it in my data information here. And with that, we do the same using pivot wider, coming from P class, values percentage, and we're going to eliminate the third class. That's the third column, that is N. We don't need it because we have calculated percentage, and as you can see, percentage I multiply by 100. It's gonna be different than the previous radar. Okay, we have now them. You can see here back sec 1, 2, and 3. We just can change the name of each column, class 1, class 2, and class 3, and for this one, it's gonna be kept as sex. Let's see, call names, and finally we have them. Okay, perfect. Each corresponding frequency of each sex by class. Okay, let's see the visualization is almost the same, but as you can see here, I'm gonna use 70 as my max grid because I have 60% here and the minimum of 0. And now that's saying that our value, different values to our plot here to the right, and we call it generator. Now we can compare male and female in each class. As you can see here, as you can see here, the distribution of each sex by class is similar. You can see that in the third class has more male and females than the other classes. This is where we can use a radar plot. We can compare different groups and different categories at the same time. In this case, we have 2 categories for sex, 3 categories for class. This is one example of an alternative plot than the bar plot. Speaking about that, we can do it with BARPLOT. You can see here, we're going to use geom call, and we only have to add something. We have to add field by sex. That means we're going to use it for comparing by sex. And position dodge is important because that way we want to do it side by side. Without position dodge, it's not going to be able to compare the different bar height by sex. And let's see. Beautiful. As you can see, you have 2 different visualizations to compare different categories for 2 or more categorical variables. You have a bar plot or you have a radar or spider web. You can see here we can see that same comparison. In the third class, we have more female and males than the other classes. We can compare, if we only focus in female, that distribution of these classes by sex, beyond need sex, or we can compare both. So that distribution looks similar. This is how you can plot different plots using ggplot in R, and we discover what is a radar or spider web.